We learned so far how to write a vector with its component or in terms of I and j. So when we have, for example, vector v, so if you want to show with the components, we show with the two components a and b, which a is a number along the x-axis, b is along the y-axis. If I want to show in terms of I and j, we can write it as a ai plus bj, because I is a unit vector along the x-axis, which its magnitude is 1, and j is a unit vector along the y-axis with a magnitude of 1. Now, we want to see how we can write a vector in terms of its magnitude and its direction. If we look at this vector on the picture, so as you see, this vector creates an angle with the x-axis, and we know that the length of the vector is called its magnitude. Now, if I want to rewrite this one as in terms of the magnitude and the direction, direction means the angle. That means I need to use some trigonometric function to show a and b based on those trigonometric functions. So right now in this formula, this is my a and this is my b. And how we can find them, just if you look at this right triangle over here, you know that this is the a and this one is the b. And if this is angle data, we can use a reference angle by just looking at this angle. And in this angle, if I want to find the sine of this angle, the sine is opposite over hypotenuse, which is b over the magnitude of the vector v. Or the cosine of this angle is the adjacent over hypotenuse, which is a over magnitude of v. And if you do the cross multiplying, you will see that the a must be equal to the magnitude times cosine. B must be equal to the magnitude times sine. So that's why we can rewrite the vector in this form. If I want to write it in terms of the magnitude and the direction. So instead of a, we use magnitude times cosine. Instead of b, we use magnitude times sine. Let's look at an example. It says write a vector with length 7, which means the magnitude is 7, and an angle of 135 degrees to the positive x-axis in terms of the magnitude and the direction. When it says the length is 7, means the magnitude of this vector is 7. Now, if I want to write it in terms of the magnitude and direction, I know that I can rewrite a vector in this form. Magnitude times cosine, it's the a, and the magnitude times sine, it's b. So we just need to replace the numbers. Magnitude is 7. 7 cosine of the angle is 135 degrees. 7 sine of 135 degrees, which is the b. Now we just need to find the sine and cosine of 135. So 135, it's an angle in the second quadrant. To find the sine and cosine of 135, I can use the reference angle, which is 45 degrees. So, which means the sine of 135 degrees should be the same as the sine of 45 degrees. But just we have to pay attention that the 135 is an angle in the second quadrant, and in the second quadrant the sine is positive, so I keep it positive, and the sine of 45 is root 2 over 2. To find the cosine of 135, again I'm going to use the reference angle, which means the cosine of 135 is the same as the cosine of 45, but since in the second quadrant the cosine is negative, I have to keep it negative. And the answer is negative root 2 over 2. So I'm just going to replace these numbers and replace negative root 2 over 2 for the cosine and replace positive root 2 over 2 for the sine. And if I multiply the fraction, multiply the numerators together and the denominators together, I get negative 7 root 2 over 2 I plus positive 7 root 2 over 2j. And this is my vector if I want to rewrite in terms of the magnitude and the direction. Now we can find a dot product of the two vectors. A dot product of two vectors, which is a scalar. Scalar means just a number. When we have a dot product of two vectors, however, we are multiplying two vectors, the answer for the dot product is always a number, not a vector anymore. Okay? And how we find the dot product? By just multiplying the corresponding component. So we have two vectors v and w here. So we multiply the components of I, a1 times a2, and the components of j, b1 and b2, and then add them together. And it will result it into just a number. So remember, the dot product cannot be a vector anymore, just a number, a value. Just find a value for the dot product. So we always remember this one whenever they ask us to find the dot product. In this example, we have two vectors v and w, and we want to find these dot products. The dot products of v times w. I want to multiply v by w, okay, which means I need to multiply the I components and the j components. So 7 times 2, negative 4 times negative 1. So if I multiply 7 by 2, I get 14. I multiply negative 4 by negative 1, I get positive 4. And 14 plus 4 gives me 18. And as you see, the result of the dot product is just a number. To multiply v times w, w times v, this time we start with vector w, but nothing else changed. We just multiply the first component and the second component. Multiply 2 times 7 and multiply negative 1 and negative 4. So we get 2 times 7 again is 14. Negative 1 times negative 4 is positive 4. 14 plus 4 is 18 again. Which means in the dot product, it doesn't matter which vector comes first. We still get the same answer. Okay? And to find w times w, the dot product of vector w by w, I just need to multiply the w by itself. And the vector w is 2i minus j. So, and if I multiply 2i minus j by 2i minus j, I get 2 times 2, which is 4. Negative 1 times negative 1, which is 1. And 4 plus 1 is 5. And these are some properties of the dot product. If we have three vectors, u, v, and w, and c is a scalar, is just a number, we have all these properties. First of all, u times v is always the same as v times u, as we worked on the example as well. So in this example, we show that the v times w, that's the same as the w times v. To multiply a dot product of a vector by sum of the two other vectors is the same as the sum of the dot product of that vector with each of the vectors in the parenthesis. So it means u times v plus w, that's the same as the u times v plus u times w. It's kind of distributive property. If we have vector 0 and we multiply it by, if we find the dot product of a vector 0 by the vector v, the result is just 0. And we know that the result of a dot product is always a number, so not a vector. So the result is just number 0, not vector 0. Number 4, a dot product of the vector by itself, it's like a square of its magnitude. And if we have a scalar c multiplied by a vector u and then find the dot product of that new vector by vector v, it can be same as if we find the dot product of the u and v first and then multiply by c. Or it also can be the same if you multiply that scalar c by vector v and then find the dot product by u. So all of them are possible, are the same. We have another formula for the dot product, but this time this product is using the magnitude and the angle between the vectors. We say if v and w are two vectors and data is an angle between the vectors, we can also say that the dot product of the v and w is the same as the multiplying the magnitude of v by the magnitude of w times the cosine of the angle between them. So that's another formula for the dot product. But for sure, the first formula is much easier. So every time we have the component of the vector and they ask us to find the dot product, we are going to use that formula. When do we use this one? If only angle and magnitude is given to us, or we mostly use this formula if they ask us to find the angle between the two vectors. That is the best formula for us to use for finding the angle between the two vectors. And that's how we find an angle. So we had the formula. To find an angle or to find the cosine, we just need to divide both sides by these two magnitude because we need to isolate the cosine. So that's why if we divide both sides by the magnitude of v times the magnitude of w, we get that the cosine of theta is v times w divided by, these are all vectors, remember, magnitude of v and the magnitude of w. And this is how we find the cosine of the angle in between. And then we use cosine inverse to find the exact angle. So next example, it says find an angle between these two vectors. The two vectors are given to us and we want to find the angle in between. The formula that we have to find angle is this formula. And for this formula, I need to know what is the dot product of the two vectors and what are the magnitude of each of these vectors. So we need to find them first. We need to find the dot product of the v and w first. And we know that the dot product can be found by the first formula by multiplying the corresponding component 4 times 1, negative 3 times 2, and then add them together. So it's 4 minus 6, which is negative 2. So the numerator is negative 2. And we need to find the magnitude of each vector as well. So how do we find the magnitude of vector v? By just using the formula a squared plus b squared. And a and b in vector v are 4 and negative 3. And if I square them and add them together and take the square root, I get root 25, which is 5. I need to find the magnitude of w as well by squaring 1, squaring 2, add them together and take the square root, which is square root of 5. So it means that the numerator is -2. In the denominator, I got 5 times root 5. So you can rewrite it like this by finding each of those separately, or you can do the same as the what's done in the slide, and then write it in this form. They are the same. Now the question is that this is the cosine of that angle. So how much is the angle? Now I need to use the cosine inverse by using the calculator. The cosine inverse of that number is 100.3 degree. And when it says rounded to the nearest tenth of a degree, that means just one decimal after the one digit after the decimal points. So the angle between these two vectors is it's around 100 degree. Next example, we want to find the angle between these two vectors. Okay, so again, we are going to use the formula because we know the cosine of the angle in between is equal to the v, the dot product of the two vectors, divided by the magnitude of those vectors. So I need to find each of them first. What is the dot product of v and w? So multiplying the components, a1 times a2, b1 times b2. So a1 times a2, -3 times 4, b1 times b2, which is 2 times -1. And if I add these together, I get -3 times 4, which is -12. -2 times -1 is -2, and -2 minus 2 is -12 minus 2 is -14. So the numerator is -14. Now we need to find the magnitude of each vector. The magnitude of vector v, which is the square root of a squared plus b squared, which is -3 squared plus 2 squared. That's 9 plus 4, and that's the square root of 13. And 13 is not a perfect square, and I cannot simplify that because that's a prime number. There is no factor for that. I need to find the magnitude of the second vector, vector w, again using the square root of a squared plus b squared. 4 squared is 16, 1 squared is just 1, and 16 plus 1 is 17. Again, 17 doesn't have any roots, so we need to keep it with the radical. Now, I can multiply the denominators because both of them are under the same radical. So if I multiply 13 by 17, it gives me 221. And I know that's the cosine of the angle in between. Now, to find the angle, I need to use the cosine inverse. So the cosine inverse of -14 over 221. And I need to put this one in the calculator. And if you put it in the calculator, you will get 160.3 degrees. That's the angle between the two vectors. If you graph the vectors, you may be able to see that angle because the first vector is 4 and -1. So that's angle W, it's the vector W, sorry. And the vector V is -3, +2. And you can see that the angle between them, it's around 160 degrees. Now let's see, when do we have parallel or orthogonal vectors? The two vectors are parallel when the angle between the two vectors is 0 degree or 180 degree. When we have a 0 degree between the vectors, it means the vectors are on top of each other or they are in the same direction. That's vector v and that's vector w. So there is a 0 degree between these two vectors. That's why we call them parallel vectors. If we have 100-degree angle between them, it means if this is angle vector V, that's vector W, and you will see 180-degree in between. So in this case, also we call the two vectors parallel, but the only difference that these two have, that if the angle in between is 0 degree, the vectors are in the same direction, but if the angle in between is 180 degree, that means the vectors are in opposite direction. When do we have an orthogonal vector? Orthogonal means like a perpendicular. When do we have perpendicular or orthogonal vectors? When the angle in between is 90 degree. So what happens now? If angles between the two vectors are 90 degree, we learn about the formula to find the angle between the two vectors. Okay, and that's the formula. This is the formula that helps me to find the angle between the two vectors. If the angle between the two vectors is 90 degree, the cosine of 90 degree must be equal to this formula. How much is the cosine of 90 degree? So since 90 degree, it's on the unit circle is over here, this cosine is 0. So the cosine of 90 degree, I know that's a 0. And it tells me that this whole fraction must be equal to 0. And I know when a fraction is a 0, it's equal to 0, that means the numerator must be 0. Because the denominators, it doesn't matter what's the denominator, 0 divided by any number, it's always 0. So if it means that the dot product must be equal to 0. So anytime that the two vectors are orthogonal, that means the dot product of those two vectors is 0. Okay, now this helps me to find if the two vectors are orthogonal or not. For example, it asks us, are these two vectors orthogonal? How do we know if they are orthogonal? We know they are orthogonal if the angle in between is 90 degree. And if the angle is 90 degree, that means the dot product must be equal to 0. So to show if these two vectors are orthogonal, I only need to find the dot product and show if it's equal to 0. So how do we find the dot product? So the dot product of the two vectors are a1 times a2 plus b1 times b2. Just multiply the component. And a1 times a2, 2 times 6, b1 times b2, 3 times -4, 2 times 6 is 12, 3 times -4 is -12, and 12 minus 12 is 0. And as you see, the dot product is 0. And if the dot product is 0, we can say that these two vectors are orthogonal. So anytime they ask you that if the two vectors are orthogonal, you don't need to find the angle in between and makes it harder for yourself. You just need to find the dot product and show if it's 0 or not. We are going to use the dot product of two vector also to solve some application or the word problems. And one of the formula that we use, it's the work problem. And what's the definition of work? The work that is done for doing something, which we show by W, it's always done by a force, which we show by vector F, to move an object from one point to another point. And that tells me that the work, or W, that should be equal to the F times AB. The vector F, which is the force, times the vector or the dot product by vector AB, which is moving from object A to moving object from A to B. So we're going to use this formula to solve some application that for needs work and the force that is done to complete the work. So let's look at an example first. And just remember that this F is the vector as well, and AB is also a vector, okay? For example, it says a child pulls a wagon along a level ground by exerting a force of 20 pounds on a handle that makes an angle of 30 degrees with the horizontal. That's the ground. So there is an object over here, and that's a wagon along, and it's a force of 20 pounds, okay, which means the F is 20. And the angle that that handle makes with the horizontal line is 30 degrees. We want to see how much work is done pulling the wagon 150 feet. When it says pulling 150 feet, that means moving object from point A to point B, or the vector AB, it's 150. Force is 20, that means the vector F is 20. But not the vector. Vector cannot be equal a number. The magnitude of those vectors are 20 and 150. Okay. So when it says the force is 20 pounds, you know the vector cannot be a number. Vector is always based on in terms of I and J. It has to have two components. But when it says the force is 20 pounds, that means the magnitude of the vector F is 20. When the work is done by pulling the wagon 150 feet, that means moving object from point A to point B, but the magnitude of that vector is 150 feet. Now I need to have the formula, which W is F times AB, but you know the formula, but the formula is the dot product of two vectors. To solve this problem, I don't need the vectors, I need the magnitude. That's why we're going to use this formula for the dot product, because that's an alternative formula for the dot product. So instead of using the formula A1 times A2 plus B1 times B2, because the components is not given to us, we are going to use this formula for the dot product. And the dot product of the two vectors is the same as the magnitude, multiplying the magnitudes times the cosine of angle in between. And now we know that the magnitude of vector F, or the force, is 20. The magnitude of vector AB, or how much the wagon was pulled from A to B, is 150. And I know the cosine of the angle, which is 30 degrees. Then we put the numbers, and then we know that the cosine of 30 degrees is √3/2, but you can just put it in a calculator to find an exact value, which is 2,598 foot per pound. So the work that is done here is approximately 2,598 foot-pounds. Then the unit is foot-pounds because vector AB is based on the feet and the force is based on the pounds. In trigonometry, we also have the topic of bearing. What is the bearing? The bearing from point O to point P, it's an acute angle which is measured usually in degrees, and it's between the ray OP and the north side line. That's a north side line. Okay, we usually, when we talk about the bearing, we talk about the angle that is between the north side line and that ray. And to show the bearing, we need three parts. One part is showing the north or the side lines. We want to know that these array have an angle with the north side or the south side. We need to know the angle in between. And we also need to have a letter of E or W, which means the ray is on the east side or on the west side of the north-south line. So we need to show bearing. We usually use these three parts. For example, if you look at this picture, you will see that this array, it creates a 40-degree angle with the north-south line. Since the angle is in between the north part, so we put north N first. The angle is 40 degree, I put 40 degree. And since the ray OP is on the east side of this line, we put E here. So that's the bearing of that option, that ray OP. Okay, now I just want you to know this bearing, because when you are working on the problem, in some problems are talking about the bearings, and you need to know what does this bearing mean. Let's look at an example now. It says a small boat leaves the dock at Camp D and heads across the river at 24 miles per hour. Relative to the water at the bearing of S 52 degree west, the river is flowing due west at 4 miles per hour as well. And what's the boat's through speed and heading? Okay. Let's read the question again. It says, small boat leaves the dock at Camp D. So let's think this is the Camp D. Let's show the four sides, northwest, east, west. Okay. Heads across the river at 24 miles per hour. So remember that these 24 miles per hour, that's the magnitude of the vector. And the bearing is S 52 degree west. That means the angle that this creates is with the S, this S with this line. That's a 52 degree angle on the west side. So west side of this line is this part. And the angle in between is 52 degree. Okay? It also, when it says that the speed is 24 miles per hour, that means the magnitude of this vector, let me just make the vector longer. The magnitude of this is 24. The length of this vector is 24. The river is flowing due west at 4 miles per hour. When it says due west is this side. When the river flowing due west in this direction, and the magnitude is 4, okay, so when the magnitude is 4, but we know the direction is on the west, not going up or down, that means if I want to write the component of this for the river, so the components of this vector for the river are -4 and 0. -4 because the speed is 4 miles per hour to the west, and the west we know is negative numbers. And when it's just going to the west, not up and down, that means the y value must be 0. So the component of the vector, if I have a vector for river, the components should be -4 and 0, and the magnitude of this must be, if I just show by r, it's 4. Now it says, what's the boat's through speed? Because we know when it says the through speed, because the boat has a speed of 24 miles per hour, but we know also that the river also have a speed that helps the boat. So those together gives me the boat's through speed. But to find the speed, I need to find a vector for and the boat first, the exact vector. Because if I want to know the speed and the heading, I need to have a vector. To find the vector for boat without considering the river, I need to use this right triangle to find A and B. Because this is A along the x-axis and this is B along the y-axis. And how do we find A and B in this right triangle? By using the sine and cosine of the 52-degree. Because I know that the sine of 52-degree in that right triangle, it's opposite over hypotenuse, which means A must be equal to 24 times the sine of a 52-degree. But as you see in this picture, A is on the negative direction. A should be negative, that's right, because it's on the west. So don't forget to keep it negative. So the answer, if you put it in the calculator, 24 times sine of 52-degree, the answer should be 18.91. I need to also find the B by finding the cosine of 52-degree, because the cosine gives me the adjacent over hypotenuse, which means B is equal to 24 times cosine of 52-degree. But B is also negative because it's under the x-axis. So also I will keep the B negative here. So the answer, if I put it in the calculator, it's negative 14.78. Now I have components of the vector for both. So for the both, we have this vector. A, which is the first component, is negative 18.91, and the B is negative 14.78. But these are the component for just the boat. But we know that the river is also helping the boats. Okay, just now we need to add these together, added by the vector for the river, which is negative 4 and 0. How do we add two vectors? Add the corresponding component. Add the first component, adding the second component. And if we add the component negative 18.91 minus 4, it's negative 22.91. And negative 14.78 plus 0 is still negative 14.78. Now this is a true vector for the boat by considering the boat and the river together, because river is also helping the boat. Now after finding the vector for boat, I need to find the true speed now. And I know the speed is the magnitude of the vector. So remember that the speed is the magnitude of the vector. How do we find the magnitude for this vector? Square root of a squared plus b squared. And for sure, I need a calculator. Square these numbers, add them together, and then take the square root. And the result will be approximately 27.3. And that's the speed, which we show the speed, but mile per hour. Mile per hour because the speed is, you see, the speed was based on mile per hour for both a river and boat. So that's a true speed now. Now I also need to find the heading of the boat. That means the direction. When it says what's the boat's true speed and heading, that means what's the boat's true magnitude and direction. How do we find the direction, the true angle now? Because this 52-degree angle was the angle for just when we had the boat. But now, based on the speed of the river, we may have a change in the direction of the boat. So we need to find that angle now. How do we find the angle? How do we find this angle? By knowing this time that the A is negative 22.91, and the B is negative 14.78. We just want to find the through angle for the direction. And the angle, since we have the opposite and the adjacent of the angle, we can use the tangent. And the tangent of that angle is opposite over adjacent. And to find the angle, I just need to use the tangent inverse. And the tangent inverse of that fraction tells me that the true angle is 57.2. Okay, so the angle is not 52 anymore because of the speed of the river changed the direction of the boat. So now the through angle is 57.2. So the through speed is 27.3 and the heading or the angle is 57.2 degree.